So now we come to another front where maybe the subject matter is a little bit different, but as we will hear, it touches upon the same problem, namely, the oligarchical structure, and can we get rid of these structures in order to guarantee for our own survival as civilization? Professor Pulinets is going to speak about the precursors concerning earthquakes and other seismic phenomena.
Okay, we had meeting yesterday. We discussed many problems, and I decided a little bit widen the title and content of my presentation, and I will continue the issues which were raised by Professor Evert in his presentation, and we'll start with climate change, okay? Because all these issues are connected with the same physical mechanism, and I would like to show you how the simple physical laws and processes can play a very important role in our life, in our environment. The main thing which we will touch now, the processes which are connected with the ionization of air of our atmosphere. Actually, we have two main sources of the ionization, natural sources. The first one, it is a ground. It is Earth's radioactivity. We know that the Earth's crust contains uranium, and the products of the uranium decay, and especially the gaseous product is radon gas, is released in any place. Even here you can measure the products of decay of radon. Okay, in the lower part you can see the ion production produced by the natural ground radioactivity. And when we go up with this profile, the more powerful source, we have our galactic. It is the main source of ionization of the upper layers of atmosphere. It is a galactic cosmic rays, which are born in our universe, are accelerated in the neighborhood of the new stars, and then penetrate to our environment and make very strong changes, including the climate change. But first, let us look what processes are connected with ionization. If you have the neutral particle and you have some energetic particles which collide with the neutral molecule of gas, you can obtain the positive ion by releasing of the electrons from its envelope. And free electrons can be attached again to the neutral particle and form the negative ion. So, but all the time in our atmosphere we have the water vapor. The water molecules structure is not symmetrical. It has a dipole structure. So one part of the water molecule is charged or contains the positive charge of hydrogen, and another one the negative charge of oxygen. So because of its polarity, they become to be attached to the ions, and this is a very interesting thing which in many works it doesn't take into account. You probably know the proverb that watched pot will never boil. Why? Because to convert the liquid water into the vapor, you need the additional energy, which is named the latent heat. Because the free water molecule has more energy, it flies in the air, and the liquid water is connected with molecules and has no such movement. So this additional energy which is necessary, it is so phase transition of the phase state of the substance. Now we're speaking about water. It is named the latent heat. So when you need to transform the liquid water into the vapor, you need to add some energy. When the water molecules became to connected with some molecule, they release this energy in the form of heat, and this is named the latent heat. And we will look on the role of the latent heat in many processes in our environment. So let us start first on the formation of the drops, formation of the clouds. So when it was discovered recently, there are many scientists who are working in this area, and most probably known it is Fritz Christiansen, who made discovery that cosmic rays, galactic cosmic rays, are responsible for the formation of the clouds. So why? Because the ions became very good centers of the condensation. When the cosmic rays enter into the atmosphere, they produce a lot of ions, and water vapor became to be condensed, and these particles grows in their size up to the size of the water drops in the clouds. So, and these new formed ions and clusters are entering in different chemical reactions. So you probably heard that we have a sulfur acid in our atmosphere, nitric acid, and many other species which are formed during these reactions, in which the ions and hydrated ions with attached water, enter in the chemical reactions. So this is all. Now we start about the global change. This is a cartoon of the cosmic rays, how they enter in our environment. They are very energetic. They have giga-electron volts energy, and they produce so-called the cascade decays, producing many energetic particles. These particles again collide with the atmospheric molecules, and this is named like a showers, the particle showers. Okay, and what made Svensmark and Christiansen in one of their first publications, they made the correlation between the variations of the fluxes of the galactic cosmic rays and global cloud coverage. And you can see they found very good correlation between these. So they did not presented the physical mechanism of this. Simply they demonstrated the existence of the correlation. But now probably you know in CERN in Switzerland there is active the huge project which named CLOUD, and they with the special particle accelerators study the processes of cloud formation with the process of ionization. So but in all the publications you meet in the literature, practically nobody take into account the another process, the latent heat exhalation during this process. Everybody looks only on the formation of the particles, formation of clouds. But together with formation of clouds, We have also the positive effect in the level of the tropopause. It is a level of between 10 and 15 kilometers, which is continuously heated by the release of the latent heat. So, and now let us look, does really we have this global heating and change which were heard before in the previous presentation. In this slide, you can see the derived from the analysis of the radioactive isotope of carbon and of analysis of stalactites in some cave in, I don't remember where, which indicate the number of the precipitating water. And this analysis made for the thousands and hundreds thousands of years. And you can see, and this carbon shows the activity of the galactic cosmic rays. And you can see that precipitation and galactic cosmic rays are in very good correlation. And now about the origin of the long time periodicity in these variations, the shorter periods which we heard about 100 years, the periodicity of solar cycle 11 years, and very short periodicities, so-called Forbush effect, which lasts 1-2 days during geomagnetic storms. So the largest known periodicity is probably connected with the position of the solar system within our galactic. You know that our galactic is spiral, and from time to time solar system enters to the arms of our galactic where the density of the matter is higher, so the fluxes of galactic cosmic rays are lower. So if we have lower galactic cosmic rays, lower cloud coverage, so we have rise of the temperature in the Earth. Between the arms, more galactic cosmic rays, more cloud coverage, we have the drop of the temperature. And here you can see the, okay, here it is millions of years, showing the correlation of the glacier periods and warming in the Earth connected with the position of the solar system in our galactic. And it is, there were a lot of studies, and you can find it is a very popular issue now. 75% of variation of the global temperature in the scale of the hundreds of thousands of years can be explained by the variations of the fluxes of galactic cosmic rays. So, and here we have the different scales, and of course the solar activity produces the modulation of the galactic cosmic rays, because you know that our magnetosphere is immersed in the solar wind. And during the higher solar activity, the density of solar wind is higher. It presses on the magnetosphere and make it to compress. So it is more obstacle for galactic cosmic rays. So during high periods of higher solar activity, also the fluxes of galactic cosmic rays are lower. And we observe the modulation of the climate with the activity of the sun. You probably, it was demonstrated earlier, so-called the Maunder minimum during the Middle Ages, when in Holland all the channels was covered by ice, and people made skating and so on, and now they are never freeze. So we have a different periodicity and different sources of the modulation of the galactic cosmic rays. All these periodicities were discovered in the variations of the global temperature of our planet. So, and now there are growing a lot of scenarios and models how it works, taking into account the different mechanisms, different processes. I will not go deeper. We have no time, but believe me that this thing is developing very sharp, and now a lot of people involved in these studies. So, probably you heard that and you feel by yourself that our climate and weather became very unstable. So we have oscillations of the weather to more extreme conditions, from higher to lower temperatures, higher winds, cyclones. And here you can see how increases the variability of the production of ions during the last decades. Probably this is one of the reasons of such variability of our climate. And this is a very beautiful example. The people make measurements in underground, registering the secondary cosmic rays, and make correlation with the temperature in the level of stratosphere. And here you even cannot see the blue line under the red one. Red one shows the temperatures of the winters 2003, 2004, 2004, 2005, 2005, 2006, and 2007 exactly repeat the variations of the fluxes of galactic cosmic rays. Okay, and it was a surprise for me how strong the role of the latent heat. If we take the total balance of the thermal energy of our atmosphere, so only 42% is provided by the direct sun heating. And as you can see, 48% are dependent on the changes of the transforming. You have dew in the morning and in the evening, and every day you have transformation of evaporation and condensation, and daily variations of the temperature in 48% are dependent on this transformation in the latent heat. So it was the first part of my presentation connected with the role of the ionization in the so-called global change or periodicity of the changes of the climate in our planet. Now we are going to the next item. It is earthquakes. I have seen a very interesting presentation of the LaRouche television about the Ring of Fire. I would like to demonstrate you how it works. It is a few months, even less than few. It is November, December 2004. And you can see the how earthquake developed, and all earthquakes have magnitude higher than 7. So the first one, the second, fourth, the third, fourth, fifth, and Sumatra earthquake. So it shows that all the ring is activated, and we see the movement of the earthquake around this ring. So now we will talk about the processes which are connected with the preparation of the earthquake. And first of all, I would like to explain my approach to this. This graph shows the distribution of energy of the earthquake and comparison with other processes which we know. So it does not take into account the recent strong earthquake. The strongest in the 20th century was the Chilean earthquake in 1960. The second one was Good Friday earthquake in Alaska in 1964. So this is to the left part of the graph, two upper points. And to the right, we have the second from the top. It is the largest nuclear test made by the USSR in the Novaya Zemlya, which equivalent to the 56,000 billions of tons explosion. So you can see how powerful are energies which are released during the earthquakes. And when people say you that it is impossible to predict earthquake, but nothing sing, it is a stupid you cannot imagine, even if you want to make the nuclear bomb, there are also precursors. There is organized some place where it's produced. You hire the people, and you can track all these processes before the production of this bomb. The same is with the earthquake. Such huge energies, which should be released during one moment, it is impossible that Earth do not manifestate anything before this. So we use so-called the physical approach and use the so-called the physical precursors. And one of the first papers was published by Scholz, who divided the process of the earthquake preparation from the previous earthquake to the next in the same place. And you know they come with some periodicity in different places. This periodicity is different. But for strong earthquakes, this periodicity from 30 to 70 years between the earthquakes. And we are looking on the last stage, which is few months, few weeks before the earthquakes. And there were several parameters which were monitored by United States, by Soviet Union, and other countries in 70s, in 80s, and there was a large hope that this problem will be resolved. But after a few fails in 1996, 97, there was discussion in Science newspaper. Leader of this discussion was a professor of Tokyo University, Robert Geller, and seismologists decided that prediction is impossible, and it was prohibited to use in scientific literature the word earthquake prediction. The scientists were punished, it is really so. The scientists were punished for using this, and their papers were not published, especially in Journal of Geophysical Research Letters, the Bulletin of the Seismological Society of America, so on, so on. Fortunately, the situation is now changing. In 2005, simultaneously in the United States and in Russia were re-established the councils of the analyzing the different kind of earthquake prediction. But still, we are in situation that majority of the Seismological Society claims that it is impossible. So I will start very short with our model, which explain how these processes are developing. Because I'm, from the origin, the space physicists, we not go deeper underground. We start from the ground surface and go up and study what processes are developed within the atmosphere. So the first square, we consider this activation of the tectonic activity, which is manifested in the activation of the faults where the earthquake will be realized. And we have the storing of energy, increasing of deformation of this area, and with increasing deformation, the new restructuring is inside the Earth happening, and we have the gas migration. You know, from the oil prospecting, the methane, carbon dioxide, hydrogen, helium are going from the ground to the Earth's surface. And they carry with them the radon, which start to be very active in the area of the active tectonic faults. So I will not explain all the model. We will see the pictures, so please relax. These are the figures showing the activity of radon when you have the cross-section across the tectonic fault. You see how drastically grows the concentration of radon in the center of the active tectonic fault. And here you see the some examples for the several strong earthquakes, how radon is developing its activity before the earthquake. The first is the Kobe earthquake, 1995. Second, it is a Mexico Copala earthquake close to Acapulco. It's 7.2, 7.4. This is a typical variations for the many earthquake in Turkey. This is the only country where the radon monitoring was not cut like in United States or in Russia. They obtained the $11 million for the project of the Putin radon sensor all over the country. And the last example, it is Signor Gioacchino Giuliani. The red curve shows the sharp increase of radon activity before the Aquila earthquake. And now let's go to our mechanism. If radon is going up and radon is radioactive, it emits the alpha particles of higher energy, which produce the ionization. Then we know now this mechanism, condensation of water vapor on ions and heat release. And if you put on the satellite infrared sensor, you will be able to detect the difference of the temperatures on the ground surface. And you can see the structures of the active tectonic faults in India before the Gujarat earthquake. Okay, not before, the faults exist all the time, but these faults were activated. And to the right, you can see the red lines which follow this system of the tectonic faults. It is a registration from the Terra or Aqua satellite with the MODIS device, the infrared emission, which demonstrates the heating of the area exactly in the place of the active tectonic faults. So, and what consequences of these processes? If you have the condensation of the water vapor, so you should have less free water vapor in the atmosphere, so you should observe the diminishing of the relative humidity. And the left upper graph shows the drop of the relative humidity in Islamabad before the 2005 Kashmir earthquake. The right one, it is the satellite measurements of the surface temperature increase at the same area. There are some techniques which permits to measure the fluxes of the anomalous fluxes of latent heat, and in the bottom row, the left picture shows the anomalous flux of the latent heat. It's the same area of the Pakistan. The next one shows the so-called outgoing long wave radiation. It also infrared emission, but it is measured in the altitude of top of atmosphere or in the tropopause. Again, it is between 10 and 15 kilometers. And you see the red spot close to the epicenter of the impending earthquake. And the last picture shows the development of the anomaly of the electron concentration within the ionosphere. So you have a lot of parameters, a lot of anomalies in the atmosphere which could be measured, and all of them appear in the same place, almost at the same time, within the period of between the 2 weeks, few days before the impending earthquake. So another example, this is a sequence of days in 2007 before the strongest quake, again in the Sumatra region. And you can see how the latent heat follow the tectonic fault or the shape of Sumatra, and it could not be explained by any other processes because all the spots are over ocean. Nothing except gases cannot go out from this. Nobody can explain it. It is impossible to explain by other mechanism. So, and the question is, how powerful is heating of the atmosphere? We know that there was some fails of the satellites because of the great magnetic storm when the atmosphere was heated and expanded up, and for example, space station was braked by the heated atmosphere and lost its height due to braking in the more dense atmosphere that it was in these altitudes. And we were able to detect the braking of the small satellite of small mass, but it had accelerometer on board the satellite. And we observe the braking of the satellite when it passes over the epicenter of impending earthquakes. In average, statistics shows that braking happens 5 days before the earthquake, and it corresponds to the statistics of ongoing long-wave radiation, which shows also the maximum 5 days before the seismic shock. And if we take completely different parameters, the top one, it is ionospheric anomalies when they appear in the ionosphere. The middle one, it is OLR, ongoing long-wave radiation. And lower one, it is anomalies in propagation of the very low frequencies in the near-ground waveguide. These signals are emitted by the navigational transmitters for navigation of submarines. It is VLF band. And all of them show anomalies exactly 5 days before the earthquake. So, and now, if you have a model in your hands and you know how it develops, you have the synergy of the many atmospheric and ionospheric parameters, and you see how process developed from the ground surface. The lower one, it is radon variation near Aquila in Italy. Then it is a surface temperature. Then it is OLR, and then it is ionospheric anomaly. And blue curve shows how propagates this process from the ground surface to the ionosphere, and then the red curve or vertical curve shows the moment of the earthquake. And this is a comparison of the, on the left we see infrared emission in the top of atmosphere, and red one, it is a distribution of electron density, total electron content over the aquila. So you are able to detect the place of the impending earthquake. And here in this list you can see a lot of other variations of electromagnetic emission, particle precipitation, so on, registered on the ground, in atmosphere, and by the satellites, and all of them show the same leading time before the earthquakes, and all of them were registered experimentally. So from experimental observation we should develop something practical to automatically detect this precursory phenomena. And first we study phenomenology of the event. We develop the physical model. We look the specific features which differ these processes from other natural, for example, variations in the ionosphere connected with the magnetic storms. From this study, we create the mask of the precursor. And then we make the statistical validation of this mask. And if it shows the good results, we produce the practical application for prediction. And you were able to see the three parameters which need to be detected. It is the position of the epicenter, time of the earthquake, and the magnitude. So position you have seen in previous slides. We quite nicely can determine the position of the epicenter. Now the time within the window of 5 days, and the magnitude from some empirical relationship we determine from the size of the anomaly. For example, this estimation one was made for Irpino earthquake in Italy by ionospheric measurements from the by topside sounder installed on the satellite. So, but still, we are criticized by seismologists that it's very nice, but has no any relation with seismology. And finally, we were happy, very happy, we found the reasonable seismologists who started to talk with us. It is Greek seismologist Gerasimus Papadopoulos, very known in the world. And he studies exactly the catalogs of the earthquakes and try to determine, okay, you have sequence on seismic shocks. What of them are foreshocks? What is the main shock? What are aftershock? And what shocks are between a long period of the earthquake? He was able to find how to determine exactly the foreshocks activity. This is again made for Aquila. He looks for the three parameters: the sharp increase of the events rate, of the number of small shocks in the area. Second, clustering of the events, so they start to be merged close to the epicenter. And there is a relationship between the frequency and magnitude of the earthquakes, and which is inside this equation there is B coefficient, which is characteristic for the process, and it was determined that before the earthquake the B value has dropped. And we tried to compare his results with our results for the Aquila earthquake. And you can see exactly when we see our precursors, he determines the foreshock activity. So finally, we found the relationship between the seismical parameters and especially foreshock activity, which says that for sure it will be earthquake, and our atmospheric parameters. So no doubt that what we are measuring are the real precursors of the earthquakes. Okay, so here we're finishing with the earthquakes, and you will ask me, if you are so clever, why you do not predict earthquakes? The answer is very simple. If you have, for example, fire in your house, you by yourself, very difficult to fight with this. You call for the firemen. There is a lot of services, emergency services. It should be created the special service. We are now, me and my friend Dimitar Uzunov, who made all the thermal measurements. He lives in the United States, I live in Russia. I am here in the conference. To make prediction, there should be people who are sitting around the clock and analyzing information in the real time scale. It should be created at least some group to make this service. We have zero financing for our research. All what I was demonstrated was made in our ordinary activity with no financing. This is a problem that to be successful, we need to create at least one laboratory aim-directed, which will have a few young people, because all this data processing is time-consuming. We sit near a computer after the strongest quake and trying to get the information all over the world, taking the atmospheric parameters. We have no service, we have no direct channels to immediately get the information on the air temperature in Japan, in Sumatra, and so on, humidity, download the data from the satellites, GPS calculating. All these need the special infrastructure. Until it will be not organized, it will not be practically resolve this problem. So the next thing about the short time variations in our atmosphere, and I would like to say a few words about the hurricanes. So it is a vertical profile of the particle production by galactic cosmic rays, and you see that the maximum of their loss and production of the particles, again, it is a tropopause in the area between 10 and 15 kilometers. It was old papers, these more modern profiles shown the particle production for different energies of the galactic cosmic rays. Imagine such situation. You have the stable flux of galactic cosmic rays. During the geomagnetic storm, the sun meets obstacle for the galactic cosmic rays, and their flux decreases sharply in very small scale, but very small period of time. So if you have less source of the ionization, less heat will be released. So in this area where we have maximum of production of the particle, we should observe the drop of the air temperature. And it happens so that in the beginning of the development of the Katrina hurricane, it was a magnetic storm. And you can see to the left, the upper graph shows the drop of the flux of the galactic cosmic rays measured by neutron monitor in the United States. The second from the top, it is a decrease of the temperature on the level of the tropopause. And you can see this is the vertical profiles of the temperature over the Katrina hurricane. Okay, it was not hurricane yet, made by the sounding by balloons, radio sound from meteorological station. And you can see the drop of the temperature. It is 8.6 degrees. It is huge amount according to atmospheric parameters. And you can imagine if you have the ocean surface temperature near 28 degrees Celsius and drop at the top of the hurricane the temperature, how increased the circulation of air. And another effect, the third graph from the top, that these changes of the temperature are not ordinary in space. And they lead model calculation shows that it's in these circumstances, hurricane changed its trajectory. And really Katrina changed its trajectory and go to the Mexican Gulf. And in Mexican Gulf, there was extremely high temperature. And convection, which was initiated, stimulated by the magnetic storm, increased more and more up to Katrina reached the category 5. So this shows that galactic cosmic rays do play a role in the intensification of the cyclonic activity, and especially in the hurricanes. And this is now the statistical work showing that the right panel, it is a drop of the galactic cosmic rays, and left one, it is increase of energy on hurricanes. It is statistical results. So again, the processes of ionization and release of the latent heat play active role in one more process in our atmosphere. Next item which I want to touch, it is radioactive pollution of the environment. We started to work with this because many people told to us how you can prove that your mechanism is working, that the thermal anomalies you observe are connected with ionization. You have plenty of sources of ionization all over the world. Please show that they are working. Okay? This picture shows the place in Africa, in Gabon, where is the natural nuclear reactor from the fossils. They're fossils with a large content of uranium. And there is increased level of radiation over this place. And you can see the thermal anomaly over the Oklo. It names Oklo Natural Nuclear Reactor in Gabon. During our history, we already have few emergencies of nuclear atomic electric power plants. Left, it is a 3 Mile Island, 1979, in United States. There was also the leak of the radioactive substances in the atmosphere. The right one, it is a Chernobyl. Again, you can observe the thermal anomaly over the Chernobyl power plant. And what about Fukushima? Here you can see the development of the thermal anomaly over Fukushima power plant up to the maximum, and then you can see the decrease of this activity. because it is a very fresh event, we were able to study the dynamic. And this is very important because it is connected with our lives. You remember that Japanese change their indicators in 1,000 times during the day, and nobody knew what is the real level of radiation. And this gives you enhance the independent source of control of radiation pollution from the satellite. And in the right picture, you see the level of the thermal anomaly. It is a bold line, and thin one shows the indicators of sensors of these explosions of the hydrogen, which carried with it the radioactive substances into atmosphere. And you can see that these explosions coincide with increase of the thermal anomaly. So another application of our mechanism and this latent heat release, it is a control of the radioactive pollution of our environment. And the last thing, very interesting, if ionization is so powerful, can we do something with our weather? Yes, we can. Okay, I spent a few years in Mexico, and there in Mexico there is a company who worked with agriculture to produce the artificial rains, and they have the installations for air ionization, produce the centers for nucleation and creation of clouds. This is a central mast, and I will not go deeply into the technology. This is examples of the real installations, and you see here the increase of precipitation in Sonora, yes, in Sonora Desert when these installations were active. But not all, this is activity during 2 years, 2003, 2004, to fill up the water reservoirs in the small hydroelectric power stations in some regions of Mexico. And you can see the 3 lower curves as individual power plants, and the red one, it is a sum of these, and you can see 2 millions of cubic meters of additional water were created by artificial influence. But it is not the last one thing. Okay, all this could be explained in the framework of the global electric circuit, which is the existence of the potential difference between the ionosphere and the ground. This potential difference is created by the thunderstorm activity, and return current goes from the ionosphere to the ground in the areas of fair weather. It is called the global electric circuit. The current is very low, but gradient of the potential is sufficiently large in the ground surface is something like 100 volts per meter. From your top to your head, you have potential difference to 100 volts. So, and if you are able to monitor the density of this current and produce the ions, you can do many things. So we have a lot of possibilities to work, but it should be very accurate. You know, it is like a nuclear bomb. We cannot give to militaries these things. It is very dangerous. But here is another example. It is simply measurements of the variation of the vertical current of the in the global electric circuit and temperature, air temperature, and you can see they anti-correlate. So if you're able to, in some area, to control the vertical electric current, you can control the temperature. So probably the result for my today presentation, we should take into account the ionization processes in different areas, and we see that they are connected with the climate change, with the detection of the earthquake precursors, with the activity of tropical cyclones and hurricanes, and there exists possibility of effects on the weather, and somehow we can sometimes correct the weather. And I would like to say a few words also about the modern science. Unfortunately, we have very narrow specialization. The people know very well only their field. And if something goes outside of their field of knowledge, it is impossible to talk with them because they do not understand, and their reply, I do not believe. We are not in church where you should believe. We are doing science. So I think that we should develop so-called, I call this the holistic approach. We should grow the scientists which have knowledge in the different fields, because here you should know the physics of atmosphere, physics of plasma, chemistry of atmosphere, atmospheric electricity, thermodynamics, and many, many other things. If you are not able at least to understand the basic things, you cannot make the progress in such matters. And this is an issue of our conflicts with, for example, with seismologists. They do not know the physics of the ionosphere. They do not know well the physics of atmosphere. But when appears in the literature or in this discussion the word earthquakes, they say, we are responsible for this, go out from this field. This is a problem, and we should resolve, we should explain that earthquake is and its preparation, it is a complex process. It envelops different geospheres which interact, and here we come to the conception of Vernadsky, that all things in our planet are connected one to another. We should keep in mind and work carefully to understand our planet. Thank you very much.